Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So let's get going. Problem: solve y double dash plus n square y equal to secant nx or d square y by dx square plus n square y equal to secant nx or d square plus n square into y equal to secant nx using variation of parameters method. So we are given a differential equation of order 2, right? Given differential equation y double dash plus n square y equal to secant nx. Consider as equation 1. We can write y double dash as d square y by dx square plus n square y equal to secant nx. Let's write d square y by dx square as capital D square y plus n square y equal to secant nx. Now take y common from all the two terms. From two terms of LHS, we'll get d square plus n square into y equal to secant nx. Consider it as equation 2. Equation 1 and the second equation in operator form is equation 2. So f of d into y equal to some function of x. Where f of d is d square plus n square. Let's now write the homogeneous equation of equation 2. The homogeneous equation of equation 2 is d square plus n square into y equal to 0. Consider as equation number 3. Now equation 3. Now we'll find the solution to the homogeneous equation using auxiliary equation, and later using the solution of homogeneous equation we'll find the general solution of equation 1. All the three equations, given equations we can say. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus n square, right? D, just replace the differential operator d by m, so that we'll get f of m equal to m square plus n square. Then the auxiliary equation becomes m square plus n square equals to 0. Now we need to find roots to this equation. We'll get m equal to plus or minus square root of minus n square, or we can write minus n square as minus 1 into n square, right? Now split the square root as square root of minus 1 into square root of n square. Since square root of minus 1 is I and square root of n square can be written as n square to the power 1 by 2, since we know that square root of a can be written as a power 1 by 2, right? And also we know that a power m whole power n equal to a power m into n. So you'll get n to the power 2 into 2, 2 into 1 by 2, which is n, or simply we'll write square root of n square as n is equals to plus or minus I n, or therefore m equal to plus or minus n I. The roots are complex conjugate. When the roots are complex conjugates, say m equal to a plus or minus ib, then the solution to homogeneous equation looks like e power ax into c3 cos bx plus c4 sin bx, right? In case of a0, we'll get e power 0 into x, which is e power 0 of c3 cos bx plus c4 sin bx. Since e power 0 is 1, so you'll get 1 into c3 cos bx plus c4 sin bx, which gives us c3 cos bx plus c4 sin bx, right? Now coming to our solution to a homogeneous equation. The solution to homogeneous equation is y equal to c3, just compare plus or minus ni with plus or minus ib, then for b equal to n we'll have c3 cos nx plus c4 sin nx. We are taking c3 and c4 instead of c1 and c2 because we want c1 and c2 to appear in the last general solution of our problem. Now we got the solution to a homogeneous equation. Using this, we'll write the general solution of the given equations just by changing the parameters c3 and c4 by functions of x, say a and b. Let y equal to, replace the parameters or constants with functions of x, a and b. We'll get y equal to a cos nx plus b sin nx. Be the general solution of the given problem. Where a and b are functions of x. So we are saying that y equal to a cos nx plus b sin nx is a solution, general solution to equation 1, say, which is nothing but it is a solution to equation 1, so it satisfies equation 1, right? So we can substitute y in equation 1. In order to substitute y and y double dash, we'll just find y and y double dash now, and we'll substitute y double dash in equation 1. Okay, in equation 1 we are having y double dash, so we'll find y dash and later we'll find y double dash using y dash. Let's now find y and y double dash. We have y equal to a cos nx plus b sin nx, and y dash equals to a cos nx whole dash plus b sin nx whole dash. So here we are having, we need to find derivative of product of two functions, right? So we are going to apply uv whole dash formula, which is u dash v plus v dash u. This gives us a dash cos nx plus a into cos nx dash plus b dash sin nx plus b into sin nx dash which gives us a dash cos nx plus a into derivative of cos nx with respect to x is minus n sin nx plus b dash sin nx plus b into derivative of sin nx with respect to x is n cos nx. This gives us a dash cos nx plus into minus minus a n sin nx plus b dash sin nx plus b n cos nx or n b sin nx. Let's write n a and n b. Right? Just remove the brackets. I'll write one more step. b, right? nb cos nx. Now write the terms involving a dash and b dash. Firstly, we'll have a dash cos nx plus b dash sin nx minus na sin nx plus nb cos nx. Let a dash cos nx plus b dash sin nx equals to 0. Consider as equation 4. Then y dash becomes 0 minus na sin nx plus nb cos nx. We'll get y dash equals to minus na sin nx plus nb cos nx. So we have considered a dash cos nx plus b dash sin nx equals to 0, so that a double dash and b double dash will not appear while finding y double dash. Okay, so we got y dash. Now let's find y double dash. We have y dash equals to minus na sin nx plus nb cos nx, right? We need to find y double dash. Y double dash equals to minus n into minus n of a sin nx dash plus n times b cos nx dash. Here also we need to find derivative of product of two functions, and here also we need to find derivative of product of two functions. So we are going to apply u v whole dash formula here, which is u dash v plus v dash u. This gives us minus n into a dash sin nx plus a into sin nx dash plus n times b dash cos nx plus b into cos nx dash, right? This is equals to a dash sin nx plus a into derivative of sin nx with respect to x is n cos nx plus n into b dash cos nx plus b into derivative of cos nx with respect to x is minus n sin nx, right? This gives us minus n into a dash sin nx plus na cos nx plus n into b dash cos nx plus into minus minus nb sin nx. This gives us y double dash equals to minus n a dash sin nx minus into plus minus n into n square a cos nx plus nb dash cos nx plus into minus minus n into n square b sin nx. Just write the terms involving a dash and b dash. Firstly, we'll have minus na dash sin nx plus nb dash cos nx. Now write the terms involving a and b. Minus n square a cos nx minus n square b sin nx. So we got y double dash here, and already we have y. So now we need to find y double dash and y in equation 1. We have equation 1 y double dash plus n square y equal to secant nx. Now substitute y double dash in 1 again minus n a dash sin nx plus n b dash cos nx minus n square a cos nx minus n square b sin nx plus n square into y a cos nx plus b sin nx equal to secant nx. This gives us minus n a dash sin nx plus n b dash cos nx minus n square a cos nx minus n square b sin nx plus n square a cos nx plus n square b sin nx equal to secant nx. So here minus n square a cos nx and plus n square a cos nx gets cancelled. Likewise minus n square b sin nx and plus n square b sin nx gets cancelled, and we'll get minus n a dash sin nx plus nb dash cos nx equal to secant nx. Consider as equation number 5. Now solve equation 4 and 5 to find a dash and b dash. We have equation 4 and 5. Just observe 4 and 5 are the terms, the terms involving a dash in both the equations. We have a dash cos nx in equation 4 and minus n a dash sin nx in equation 5. In order to cancel the terms involving a dash from these two equations, we'll just need a n sin nx in equation 4, in the first term of equation 4, and a cos nx in the first term of equation 5. So we'll multiply n sin nx to equation 4 and cos nx to equation 5. Solving 4 and 5. Just multiply the equation number 4 with n sin nx. We'll get n a dash sin nx cos nx plus n b dash sin nx into sin nx is sin square nx equal to 0. Now multiply equation 5 with cos nx. We'll get minus n a dash sin nx into cos nx plus nb dash cos nx into cos nx is cos square nx equal to secant nx into cos nx. This gives us here plus n a dash sin nx cos nx and minus n a dash sin nx cos nx gets cancelled, and we'll get n b dash sin square nx plus n b dash cos square nx equals to secant nx into cos nx. Right? Now take nb dash common from the two terms of LHS. We'll get nb dash times sin square nx plus cos square nx equal to secant nx into cos nx. Right? Since we know that sin square theta plus cos square theta equals to 1, so sin square nx plus cos square nx becomes 1. We'll get nb dash into 1 equal to secant nx cos nx, which gives us nb dash equals to secant nx cos nx. From this we'll get b dash equals to 1 by n secant nx cos nx. We know that Secant theta is reciprocal of cos theta. So let's replace secant nx with reciprocal of cos nx. Then we'll get nb dash equals to 1 by cos nx into cos nx, where cos nx gets cancelled, and we'll get nb dash equal to 1. From this we'll get b dash equals to 1 by n. Therefore b dash equals to 1 by n. We got b dash. Let's now find a dash just by substituting b dash in equation 4. We have equation 4, a dash cos nx plus b dash sin nx equals to 0, right? We can write this as a dash cos nx equal to minus b dash sin nx. Let's now substitute b dash. Since b dash equals to 1 by n, this gives us a dash cos nx equals to minus 1 by n sin nx. Now take this term, take cos nx to RHS, we'll get a dash equals to minus 1 by n into sin nx by cos nx, which is equals to minus 1 by n into tan nx, right? Therefore a dash equals to minus 1 by n into tan nx. We got a dash and b dash. Let's now find a, b using a dash and b dash. We have a dash equals to minus 1 by n tan nx, right? A dash is nothing but derivative of a with respect to x. Let's separate the variables by taking differential dx to RHS. We'll get dA equal to minus 1 by n tan nx dx, right? Where the variables are separable. Here the variables are separable. So we can apply or perform integration. Integral dA equal to minus 1 by n integral tan nx dx. Since we know that integral tan a theta d theta equal to minus 1 by a log mod cos a theta or 1 by a log mod secant a theta, then the above equation becomes a equal to minus 1 by n into, if you apply the first formula or if you use the first formula, then for a equal to n you'll have minus 1 by a, that is for a equal to n you'll have minus 1 by n log mod cos nx or minus 1 by n integral tan nx dx. For the second one you'll have 1 by n log mod secant nx, right, which is equals to minus into minus plus 1 by n square log of cos nx or minus 1 by n into n square log of secant nx plus integral constant, say some c1. Okay, you'll have an integral constant plus c1. Okay, therefore a equal to 1 by n square log of cos nx plus c1 or a equal to minus 1 by n square log of secant nx plus c1. We got a. Let's now find b. We have b dash equals to 1 by n, right? B dash is nothing but derivative of b with respect to x. Let's now separate the variables by taking the differential dx to RHS. We'll get db equal to 1 by n dx. Here the variables are separable. So let's perform integration. Integral dv equal to 1 by n integral dx. This gives us b equal to 1 by n integral dx is x plus some integral constant say c2, which gives us b equal to x by n plus c2. Therefore b equal to x by n plus c2. Now coming to the general solution. Therefore, the general solution is given by y equal to a cos nx plus b sin nx, right? Substitute a and b here. I'm going to try for the first one, for the first a I can say. Then I'll get 1 by n square log of cos nx plus c1 into cos nx plus b x by n plus c2 into sin nx, which gives us 1 by n square cos nx into log of cos nx plus c1 cos nx plus 1 by n x sin nx plus c2 sin nx, right? Or we can write it as, first write the terms involving c1 and c2. Firstly, we'll get c1 cos nx plus c2 sin nx plus 1 by n square cos nx into log of cos nx plus 1 by n x sin nx, right? Or we can take the second one, then you'll get minus 1 by n square log of secant nx plus c1 into cos nx plus b x by n plus c2 into sin nx, which gives us minus 1 by n square cos nx log of secant nx plus c1 cos nx plus 1 by n x sin nx plus c2 sin nx. Or we can write it as, write the terms involving c1 and c2. Firstly, we'll have c1 cos nx plus c2 sin nx minus 1 by n square cos nx into log of secant nx plus 1 by n x sin nx. Therefore, y equal to c1 cos nx plus c2 sin nx minus 1 by n square cos nx log of secant nx plus 1 by n x sin nx, or y equal to c1 cos nx plus c2 sin nx plus 1 by n square cos nx log of cos nx plus 1 by n x sin nx. Okay, this completes the problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.